All right, so the next thing we're going to do is move on to the third method of solving a quadratic equation, or finding the zeros of a quadratic function, which is completing the square. You're going to complete the square when the equation is not factorable and not solvable by solving algebraically. And specifically, we're probably going to only do it when the b value is divisible by 2. In other words, the coefficient on x is even. In the completing the square process, it is a 4-step process, but we're going to start by cutting out steps 1 and 4 just to make things easier. And so we're going to make it a 4-step process by only factoring or solving by completing the square for questions that have a coefficient of 1 in front of the x squared term. So we are going to solve these 4 questions, but I thought maybe first it might be a nice idea just to start with like a review of completing the square, because this is assumed knowledge, so we don't do that many examples. But let's just do like a little bit of a talk. So you don't have these in your notes. If you want a scrap piece of paper, you can, but you can also just follow along. So I've got 4 questions here that all have that even coefficient on x. So all the b values are divisible by 2. And we're going to just practice completing the square. So completing the square means making this into a perfect square trinomial that factors down to a binomial squared. So our job is to figure out what the number that we would add on the end would be to make this a perfect square trinomial. And the process is finding this magic number. To find the magic number, you take the middle coefficient, so the coefficient b, and you take half of it and you square it. Now I know it's a -6, but I don't have to put the negative on there because -6 divided by 2 is -3, which squared is 9. +6 divided by 2 is +3, which squared is 9. The key thing is that the magic number is the half the middle term squared, which is 9. And what that does for us is it creates a perfect square binomial that it would factor down to. So if I was to factor this, I'd be looking for the two numbers that multiply to give me 9 and add to give me -6, which would be -3 and -3. Because it's the same number, that means that x minus 3 times x minus 3 would give me x squared minus 6x plus 9. Checking it, right? X times x is x squared. If you had two of these brackets, right? If you had x minus 3 times x minus 3, you'd get x squared, and then you get minus 3x and another minus 3x, which would give you -6x, and then -3 times -3 is 9. So what we're going to be doing is creating these perfect square trinomials that will factor to a binomial squared so that we can solve these questions algebraically or by the principle of square roots. But we're just going to practice this process first. So x squared minus 6x, the magic number was 9, and it factored to x minus 3 all squared. If we had x squared plus 6x, to find the magic number, you'd still take half that middle term and you'd square it, but this time it's 3 squared. Does that change the magic number? No, it's still going to be 9. But what's going to change is that when you go to factor it, you're looking for two numbers that multiply to give you 9 and add to give you 6, which are going to be 3 and 3. So instead of x minus 3 in the bracket, we're going to have x plus 3 in the bracket. So when I'm doing the factoring step, I always put in the variable, which will be x for most of these, and then I always take half the middle term. So for this one, it was -6, so I put in a -3. For this one, it was a +6, so I put in a +3. It's also the square root of the last term, but it has to have the sign of the middle term, right? Because it's always squaring to get 9. And so you have to decide whether it's going to be a -3 or a +3. So I've got two more here. Again, we're just going to practice finding that magic number. So if we do half the middle term squared, half of 10 is 5. 5 squared gives me 25. That's my perfect square trinomial. This factors to x plus 5, right? The two numbers that multiply to give me 25 and add to give me +10, 5 and 5. All right, what about the last one? So again, the magic number would be -12 divided by 2 all squared, which is going to give me -6 squared, which is 36. So for this one, I'd be adding 36, and then the perfect square or the factored version would be x minus 6. Okay, so that's just seeing that part 4 times. That's the hardest part of completing the square, and then from there we just have to add on solving. So for this one, we've got x squared minus 6x, and then we've got it equal to 10. To make this a perfect square trinomial, we're going to take half that middle term and we're going to square it. So half of -6 is -3, which squared gives me 9. Now, some people actually put this into their work. So they put plus half the middle term squared minus half the middle term squared. You can do whatever you want. But I go like this, and I go straight to putting the 9 in there. And then, like I just kind of gave away, you can't just add 9 to an equation, right? This would totally change it. X squared minus 6x plus 9 equals 10 is different than x squared minus 6x is equal to 10. So you have two choices. You can add 9 and, sorry, I wrote the wrong thing there. Add 9 and minus 9 because then you're really adding 0, or you can add 9 to both sides of the equation. It doesn't matter. I'm going to consistently add 9 minus 9 because it's going to help us when we get to the questions that have a coefficient other than a 1 in front. But this is the part that's the perfect square trinomial. It's always the positive. Think something squared is always positive. So we're going to factor that to what binomial is squared? Well, x, and then the two numbers that multiply to give me 9 and add to give me -6 are -3 and -3. And then I'm going to add 9 to both sides to make that equal to 19. And then I'm left with something that I can solve algebraically. I can use the square root principle to take the square root of both sides to get x minus 3 is equal to plus or minus the square root of 19. And then to get x by itself, I'm just going to add 3. So these would be the solutions to this quadratic equation as an exact solution. So an exact solution, again, means I didn't touch a calculator. I mean, I can solve things using a calculator, but I didn't take the square root of 19. I didn't round. As soon as you round, you're introducing error, so it's not an exact solution. So for these types of questions, we will always answer with exact solutions. And then when we get to the questions that are applications, where we're going to be using the answer to describe something, then we will round to a certain number of decimal places. So then we go 3 plus root 19 and 3 minus root 19. But for these, just leave it. Okay, here's another one. So x squared plus 8x. I'm trying to think of what am I going to add to make this a perfect square trinomial? Well, you're going to take half that middle term. And again, this is, some people like to show this in their steps. I don't. I feel like it's too much, but for some people this might be like, oh, that makes sense now, right? And then you're going to take away that half the middle term squared, which means what are we adding and subtracting? Well, half of 8 is 4, and 4 squared is 16. So I'm going to add and subtract 16. Then this is the part that's my perfect square trinomial. So what's it going to factor to? Well, it's always going to be that x in front. And then the two numbers that multiply to give me 16 and add to give me positive 8 are plus 4 and plus 4. And then I'm going to solve this. So I've got x plus 4 all squared minus 16 is equal to 0. Then I'm going to add 16 to each side. I get x plus 4 squared is equal to 16. Then I'm going to take the square root, plus or minus the square root of 16. Now, hopefully you recognize that 16 is a perfect square. So we've got x equals -4 plus or minus the square root of 16, which is -4 plus or minus 4. For a question like this, to give exact solutions, this can be simplified. This one I was adding a radical, so I had to just leave it. But for this one, I've actually got two answers. I've got -4 plus 4, which would give me 0, and I have -4 minus 4, which would give me -8. So this question has two solutions, 0 and -8. In fact, most questions will have two solutions. Every once in a while you get one, but then you can also get two that are imaginary, right? But we usually get two. Even the one that's one, it's two identical solutions. So theoretically, there's still two. Now, anything you notice about these answers, right? These ones are radicals, which meant I had to solve by completing the square at this point. Because this one came out as these nice integers, it means this question was actually factorable. So when we talk about having different methods to do things, we just solved this question by completing the square. But I could have recognized that there was a greatest common factor of x, factored it out. Now this is fully in factored form because it's the product of two linear factors. And I could say that x is equal to 0 and x is equal to -8. I could get those same two solutions in two steps versus 1, 2, 3, 4, 5, 6, 7, 8 steps. So be mindful of your method, right? When there's more than one method to do a job, you're supposed to pick the right tool for the job. So for this question, definitely factor. But could I do it by completing the square? Heck yeah. All right. Hopefully you're feeling pretty good after those two. I want you to give this one a go. So solve this one by completing the square. Pause the video. Okay, so I'm just going to write this as x squared minus 2x, and I'm going to leave a bunch of space. I'm looking for that magic number. So I'm taking half of the middle term and I'm squaring it. So -1 squared, which is going to give me 1. So I'm going to add 1 to make that perfect square trinomial, but I'm also going to subtract 1 so I don't change the equation. This is the part that is the perfect square trinomial, so I'm going to factor it. I'm going to put the x, and then the two numbers that multiply to give me +1 and add to give me -2 are -1 and -1, or half of that term. And then I'm going to add the 1 at the same time, and I get x minus 1 all squared is equal to 18. Now I can solve algebraically. I'm going to take the square root of both sides. I get plus or minus the square root of 18. Now to fully answer this, I have to add the 1 to each side, but I also want to simplify my radical. So I'm going to put √9, √2, and then my full answer in exact simplified form would be 1 plus or minus 3 times the square root of 2. Awesome. Okay, we have one more question here that I didn't expect you to do, but I just wanted to show you. So this is a question where that b value is not even. And I wanted to show you that it's not that bad. Like, it is doable. You can solve any quadratic equation by completing the square when it has this b term, okay? Even if it's odd. So let's go through and do it. So we've got x squared plus 5x. Then we're looking for that magic number. You're going to take half the middle term and you're going to square it. Now, half of 5 is 5 halves, and squared would give me 25 over 4. Now, some people are like, well, why don't you use a decimal? And my answer is you totally can. I actually have recorded this video twice because the first time I was like, oh, I'm just going to use the decimal and show them how nice it is with a decimal. But then we ended up with this number on the other side that wasn't a perfect square and you had to simplify it. And so you had to put it back in as a fraction. So I was like, oh, I should just do this from scratch with a fraction just to show you that it's not that bad. But yes, you can totally use decimals, especially if this is an application question where the answer is a decimal answer, like you're allowed to approximate. Go ahead and use decimals. But I'm going to go ahead and just use the fraction just because I know where this one kind of goes. So I've got x squared plus 5x plus 25 over 4 as my perfect square trinomial. When I factor it, I'm looking for the two numbers that multiply to give me 25 over 4 and add to give me 5. It's going to be 5 halves. It's always half that middle term. So I'm going to put 5 halves in here, which if you're putting 2.5 is totally fine. And then I'm going to combine these like terms. Now, when I'm adding fractions, feel free to use a calculator or don't be afraid of them, right? I'm going to create that common denominator of 4. So I'm going to multiply the 9 by 4 over 4. So then I end up with x plus 5 all squared minus, whoops, I wrote a 24. It's a 25. What is that, 61, I think? I feel like because this is a video, I should check. Yeah, you can see I filmed it before with the decimal. Yeah, 61 over 4. Okay, so then we're going to move that to the right-hand side. We end up with x plus 5 all squared is equal to 61 over 4. Then we're going to take the square root, so we end up with x plus 5 is equal to plus or minus the square root of 61 over the square root of 4. So we're taking the whole, like the square root of the other side. We don't usually write it like that. Why don't I write it like we normally would? Square root of 61 over 4. And then I want you to recognize that the denominator is a perfect square. So this is the square root of 61 over the square root of 4. So I get x plus 5 is equal to plus or minus the square root of 61 over 2. And then my final answer, which I should have given myself more room, would be x equals -5 plus or minus the square root of 61 over 2. This is a great final answer. If you look in the back of the book, they may give that, or they may give it as -10 plus or minus the square root of 61 all over 2. And the reason they might give it to you like this is because they want everything to come out the same. And again, if you think of that quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, then this is the same form as that. Negative 5 plus or minus the square root of 61 over 2 is great, but they might have this in the back. So just be able to recognize that they are both the same. So anyway, that was a question with us persevering with a b value that was odd and it wasn't too crazy. And we even did it odd with fractions. The process stays the same. All right, go practice some of these in your homework.